let's see. What am I missing? So what am I missing in here? Let's try to maybe reverse engineer the answer, right? So we have like, I don't know, we have like alpha cube. This is an interesting thing. What if we just Google normalization factor of exponential decay? Maybe this is a thing. Oh, okay. Look at this. Okay, there actually this is something. I have an exponential decay function. Okay, so that is actually where t is time is the normalization constant for that time window. Once they found to satisfy the constant. Okay, whatever. I don't know what NT would be here. Exponential decay. Okay, so maybe there's some interesting thing here. Solutions, derivation of the mean lifetime. It didn't occur to me that that was actually a thing. Because the rate proportional to its current value. Symbolically, this process can be represented from a differential equation, exponential decay. The quantity at time t and the initial quantity. That is the quantity of time t0. And the constant is called the decay constant, the distribution constant. Okay. Half-life. Something with quantum mechanics here. No. Normalizing constant. Okay. Okay, that's not this. Exponential decay. Okay, that's this thing. Literally, that's the stuff that is in the Wikipedia, man. Okay, it is actually seems like there is. I found maybe a more detailed explanation. The given wave function can be normalized to the total probability equal to 1. So, yeah, okay, but this is for like one-dimensional stuff, right? Here there's a pi in the solution, so So I'm sure this has got to do with the polar. So where did we get finally? Python x21a dot pi. What did I do here? So what is it here? So this is the we're doing the polar stuff, are we? Because we're doing, we're saying z, or no, the cylindrical coordinates, right? So no, God. Cylindrical coordinates. I like this one. It's r d theta dr. D theta dr dz. Yeah. To become length. Yeah. B R. Correct. So maybe I'm getting the boundaries not correctly again, right? But essentially it's so we do z first from 0 to n, we're saying. The radius can be 0 and infinite. Can it though? What if we just put some value? Does this change the result drastically? Oh God, that makes it complicated. No, I think this is definitely infinite. If I put something really big, well, that's not really big, but okay, yeah, you still get some funky stuff. So, I mean, yeah, the radius can definitely be infinite, right? So, it's just a question of, okay, why? What happened? have I messed up with something or what? What have I done? Oh, now it works. Okay, so steel. Steel, like, I'm missing something, you know. I'm definitely missing something. I mean, here S3, then you already get a squared, and then here's where you get the pi, and the n being like this kind of makes sense because at the end we're getting so if we're getting the again, so what are we doing? I mean, so this is so power of, this is square of x, right? So if I so 3 divided by 2 is basically square root of like x to the power 3, right? Essentially. And so what we get here really is sort of the square root of alpha to the power 3 divided by pi and really all these to the power 3. This is what's quite crazy. But still, you know what this tells me? This tells me somehow that n had to be 2. N had to have a power of 2 for these to be like turned into a square root of things. So again, that is something I don't like because here I do get an n3 and s4. What if we say that a z can go to infinite? Does this change the result? Ugh. Yeah. Z can go to infinite. If you say z can go to 1, that's also not great. The current challenge now is that I don't know what is the assumption, if it's 3-dimensional or not. And again, the fact that basically we're doing 3 times, you know, say exponential of minus x and then times the radius, right? Say 2. So yeah, okay, this could be I mean, you know, in theory, this could be negative, right? Could it? Not even talking about complex. I mean, this could be negative. So in which case, in which case, you know, these would go from minus n to n. I don't know if that would make sense. Oh, 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 no, no. Two, this is should be 3 divided by 2 and not 2 divided by 3. That's what bothers me. Because if this can't be real, then things go nasty, I guess, right? Actually, no, things don't change so much. Interesting. Because you know, n can be complex, right? But then, oh god, then it's like then what is that really? Oh, and you know what? I think the problem, the problem here is that so this is the function, but we're looking for the square of that. Okay, so maybe this is a thing. Or is this too much? Because it's squared, there's no negative, maybe. What the heck? What? Python x2 1a. Two fourths. I don't know. The thing is, I don't know if he can I don't know if he can do that really. But that just looks pretty nasty. Why 0? Why even 0? I mean, yeah. It's still, I'm surprised that it's solving something. Bro, I don't know. Bro, I really don't know. I really don't know. This is death by not knowing. We have n. We have this stuff, right? N could be anything, really. It could be a complex number. But it doesn't have to be, because if it's an exponential decay, then it looks like, you know. It's probably not. Facot, factor. Okay. I have questions. One example about solving the radial Schrodinger equation is done with radial Schrodinger equation. This is just going too much. Like I'm just I'm stumbling. I'm like just going one way, the other, without really thinking. I'm not thinking. I'm really not thinking. I feel these. I feel that I'm not thinking. We have this function here. This function here. Let's say this is real. I don't know if I can make that assumption though, but you know, it's just I have this function here, and I wanna show that the integral of it is equal to 1. But the integral without this r, okay? And so that is the thing, right? So if it's say like 2 squared, right? And then it's twice the thing, and so this is, you know, so this is basically the radius, right? Oh, I can do this. Aha. Hey, nice. Okay. Oh, that's nice. So this is alpha, and you know, this is n squared basically. Oh, I didn't know you can do that. That's pretty cool. N squared. Ooh. Oh, look at these. For negative. For big n's goes like that for negative. Oh. 0 goes like that, and then oh, that's pretty cool actually. You can do that. So this is the value that I'm getting from this expression, right? And so the point is, I'm just not thinking. The point is, if I'm assuming we're in 2D space, I feel like this is exactly what I was doing last time. I'm sorry, but like I really have to do these. Like, this means that if you give me a point, whatever it is, with these radius in here, and because we're in 2D space, then all will give you the same z. So this means you're gonna have like a cylindrical symmetry here, and you know, this one can be maybe another value, and so it can go up, it can go down, doesn't matter. I mean, what this is telling you is that as the radio increases, the value goes lower, so you indeed kind of have like a bit of a cone shape like these, right? The question is whether this really goes all the way down. Yes, because you know, this point, they have the same radius, right? So I mean, it's fine. That is kind of that is fine. Yeah. So you go all the way around. But then the radius is 0 to infinite, right? So and the z is like you were never gonna get the result won't ever get negative. So it's really capped at 0, and it's really capped at like you won't ever get values higher than this, because otherwise your input, the radius, would have to be negative for this to happen. So it's always n squared in this case. So I'm pretty sure. I'm pretty sure that this is correct. 0 to n squared. Then you integrate on the radius, which can be 0 to infinite. And then you integrate on the angle, which is basically which is, you know, it's basically 2 pi. It should really be these, you know. It should really be these. I don't see 0 to 2 pi for B. The Z is real, positive, real, positive. Yeah, I don't know about these, but I can just tell it it's radians symbols. So sim pi radians. Can you make I don't think it matters. I really don't think it matters, to be honest. I don't think it matters because it's a real number. Yeah. Between 0 and 2 pi. I'm not so sure though. There might be here something. Let's see again. And what if we? So this could be. I'm quite sure I get it now. I'm really sure that I've gotten it. The problem is I don't get that answer. That's even more fucked up. We've got that function that is squared, and then I add the radius in there. Do I have to add the radius squared or not here? That is the problem. Because that R, I don't know. This is what I don't know. How do I redefine this unit, like the stuff, right? Because fucking makes no sense. This just makes no sense. This just makes absolutely no sense. This makes absolutely no sense. Because what I'm integrating, what I want to integrate is the probability density function. The probability density function is what I'm trying to integrate. You know what I mean, right? So what I'm trying to integrate is, this makes fucking no sense. This makes no sense at all. So yeah, but yeah, let me just I feel I got the boundaries correct, but I'm not so sure about the squares or the not squares, because the function that we're integrating over is the square, the square version of the original function. And then, so I don't know if you have to translate then the ends and the squares, you know what I mean? Like the, you know what I mean? Like, I don't know. I really don't know. I don't know if that makes a difference or not. I don't know if that makes a difference. That's the problem. That's the fucking problem. What if I would just integrate and then square? Like, does this make a difference? Like, what if I just do, I want to try, what if I just do these? What if I just do these? Does this make a difference? I integrate the thing, and then maybe maybe. No, so not these, but then when I'm here, I do like that. That probably doesn't work. Oh god, that probably definitely doesn't work. Like this. Yeah, that definitely doesn't work. No. Okay. There's something that kind of bothers me as well a bit. So getting the mechanics right, but that just that's the fucking details, man. Anyway, we keep hitting at this. We keep hitting at this problem. See you next time.